Hi, welcome. In this video, we will solve problem trapping rainwater asked by companies like Amazon, Goldman Sachs, Facebook, Google, and some others. Let's check out this problem statement. Trapping rainwater. It is one of the most famous problem on the Leetcode. It is mentioned as hard in the Leetcode. Okay, we will solve it, and will solve it by using like general terms, right? By using intuitive approach. Okay, we will solve it by using two approaches, and really going to be interesting. So let's see. So given a negative integers, that means simply positive integers, with zero value representing an elevation map where the width of each bar is 1. Okay, so these all integers, right? 0, 1, 0, 2. These are representing as an elevation, right? That's you can understand it's like an height. Okay, compute how much water it can trap after raining. Okay, so we have input given like these. This is an array, and we have an output of 6. Let's see how the output is 6. So if I simply construct an elevation by this array, so here you can see this is my array. Okay, and if I'm constructing an elevation, so here you can see this is of 0, then this is of 1 height, then this is 0, then this is 2, then this is 1, again 0, 1, then this is 3, 2, 1, 2, 1, and the width here, that is 1 of each, right? Of each. And we need to find out how much water is trapped here. So suppose if there is an raining, right? It raining. So how the water will be stored, right? So can I mention that water will be stored till here, right? This will be water zone, and here the water will be stored till here. This will be water zone, and here the water will be stored here, right? Here water won't store because it will simply flow from here, right? It will simply flow from here. So the maximum area that water can be stored here, that's the only thing that I have mentioned. Okay, so this is the water trap, and if I find out the area here, so this is of 1 width, right? And the height is also 1, so this will be 1, right? Area here will be 1, and this is also 1. This part is also 1. Okay, if I talk about this part, right? So here you can see here the height is 2. Okay, so that is 2 into 1. So this one plus 1, 2 into 1, 2, plus this is also 1. So that is also 1. And this is also of 1 meter. This is 1 with 1 height. Okay. So what is the total area covered by water? That is 3, 4, 5, 6. And that's why the output is 6. Okay. So consider it's like a real problem. Okay. So if I am considering it's a real problem, so you may be considering that water will be stored in a volume, right? How this can be an area? So you can assume that in volume we want length, breadth, and into height, right? So height is given. Breadth we are mentioning as 1 meter, right? This will be the width, and length also, like in the like here this part, right? The z-axis, this part you can assume that this all in 1 meter. So if this is also 1, so it will be something that is depending only on the breadth and the height. And if I say breadth is also 1, then it will be depending on the height, right? So water area will be determined by the height only, area. Okay, this is how you can understand it. And now let's see how we can solve this problem statement, right? So what we need to find? We need to find water trapped here. Okay, how much water trapped? So basically we are talking about the area here, area of the water. So let's see, like here the height of the water is this much. Okay, and why the water is stored here? Why this is the only region that water is stored here? Why water is stored only in this area, right? Can you guess it? Why the water is stored only this area? Can I say that? Can I say that this is because for this zeroth element, or you can say for this building with 0 height, for this building 0 height, 1 height, the adjacent buildings are taller than it. The adjacent buildings are taller than it. Basically, how water will be stored, right? If the adjacent buildings are taller than that, then the water will be stored here, right? Then the water can be collect basically. Okay, so this is the only reason why the water is storing here. So one of the observation, let's note down all the observations one by one, and then we will find out the intuitive approach. So one observation is that the adjacent height should be greater than the current height, right? So I will say that current building height. Okay, let me mention it like this. So current building height be less than the building on the right side. I can say right building height, and should be less than the building of left side. So left building height. Okay, and if I am making on a numerical term, it will be the my current element array I should be less than the left part, that is AR of I minus 1, and should be less than the AR of I plus 1, then the water will be stored, right? Then this condition exists, then only the water will be stored. Okay, so that's the observation of water will store or not. Okay, now the next observation is what will be the height of the water, how you will determine the height of the water. So can I say that first of all, I have two tall buildings on the adjacent side, right? Two tall buildings on the adjacent side. Okay, and if water is collecting here, it will collect till the lowest height. Okay, till the lowest height. Here you can see there is two tall buildings. It will collect till the low side, like so. Here I have one height. Okay, that is greater than the current element. Here I have one height that is greater than the current building, and the building will store the minimum of both, right? So I will say that my height of the water will depend on the minimum of height of the left building or height of the right building, right? Okay, that's the second observation. Now let's add all the observations one by one. So one observation is like your array I should be less than left and right. Okay, the left and right. And one observation is that height of the water will be the minimum of your height of left and height of the right. Okay. Now check, is this statement is really true that it is depends on the adjacent height of left and adjacent height of right. Okay, the next height or maybe the leftmost part. Let's check out this example here. You can see the height of water is not till this mark, not till this mark, right? Even the minimum of height of left and height of right is this one, right? It is equal to the minimum of the leftmost part. Okay, so if I am creating one step, suppose something like this. Okay, okay, and I have something like this. So if I am simply collecting water here, the height of the water will be this much, right? So it is not depending on the adjacent, mm, like adjacent left or adjacent right. It is depending on the leftmost, right? Left maximum, right maximum, right? So where what is my left maximum here? Left maximum height building, that is this building, right? Left maximum height building. What is my right maximum? This building is the right maximum building, and from this minimum of left and right we will get the height. Okay, so if I simply change it, right, it will not about minimum of height of left and height of right. It will be minimum of, okay, height left maximum and height of right maximum, right, on the right side. Suppose on the left side, suppose here if there is some tall building, right? Okay, then the height of the water will be till here, right, on the right side. So these two observations and very important observations we got. Okay, okay, Okay. So now the work is very simple. What we need to do, we need to find the like left maximum height and right maximum height. These two values we need to find it. And from this we will take minimum, and that will be the height of the water. Okay. And for the area, what we will do, we will get the height of the water, simply multiply by 1. Okay. We will get the area. Okay. Let me write it like this. Area equals to the height of the water to 1. Okay, summation of it, we take the summation of it. I will go till n, right? This will be the terms. Okay, okay. So now what we will do, we will simply calculate the height left maximum and right maximum. But how to calculate the left maximum part, right? Suppose you are standing at here, right? You don't know, like, is there any right maximum, right? So if I say about one of the building can be in future like something like this, sorry, like suppose of this height, right? That is also possible. Okay. And here the left part can be of this. So how you will figure out what is left maximum height and right maximum height? Okay. So what we will do, we will try to find out pre-calculated values for each building. Okay. Pre-calculated left maximum, pre-calculated right maximum. Okay. So what is my current building height, like 0, 1, 0, 2? So these are my current building height. Let me write it somewhere. So let's suppose 0, 1, 0, 2, 1. Let me create a table for it, then it will be very easy. So here you can see these are the height of the buildings, right? So what I will do, I will calculate the left maximum heights for each building, right? So let me put it blue pen, that is left maximum height, right? So left maximum height for each building, right? So this building is 0, so there is nothing maximum than 0, right? So I will simply put 0. Now for this, here we have 1 as a height of building, right? So what we will do, we will say for this element 0 is the, like, 0 was the only left maximum, right? This is the new height, right? 1. So what we will do, we will find out the current element, right? This element and your left maximum, right? What is the maximum height, right? Because this will become a maximum for another element, right? So I will find out the left maximum is 0, current height is 1. So which is greater? Current height, right? So I will put 1. Okay, because this will be the left maximum for the next element. Similarly, I will move. Okay, I will move. This is my left maximum. Okay, this is the current element, right? Which is greater? Okay, so this is left maximum only 1. So I will put 1. Again, I will move here. A left maximum will be here. Which is greater? That is 2. So I will put 2 here. I will move. Okay, 2 and 1, which is greater? That is 2. So I will simply move. Okay, and 0 and 2, which is greater? Which is left maximum? Again 2. And I will move. 1 and 2, which is greater? 2. I will move. And 3 and 2, which is greater? 3 now. Okay, so I will move. 3 and 2, which is greater? 3. So I will move. 1 and 3, which is greater? 3. 2 and 3, which is greater? 3. 1 and 3, which is greater? 3. So understand this. Okay, understand this. Like, so height is 0, which is the leftmost maximum height till here. That is 0. Height is 1, which is the leftmost maximum height for this. There is nothing, right? 1 only. This is the current building height is the maximum only. Okay. Then we have 0 here. What is the leftmost maximum height? That is 1. Okay. We got 1 here. Okay. For this, which is the leftmost maximum height, there is nothing maximum. This current building is the maximum height, right? Current building is the maximum height. Similarly, right, we will go and we will fill left maximum here. Similarly, if I fill the right, how I will fill the right? So I will take the right maximum height, and here we need to start it from like here, because we need to fill. So basically we are calculating prefix values and we are calculating suffix values, right? These are known as pre-calculations. So is there any building taller than this building? No, right? This current building is the only taller, right? So I will mention 1. Okay, and you can see, you can remember that your corner points. Your corner points won't collect the water, right? So these will have always like the values will be the left maximum and the right maximum. So here you can see in the left maximum height is 0, in the right maximum the height is 1, that is mentioned there. Okay, now again 1 and the next 2 which is greater, that is 2. Now 2 and the next one which is greater, that is 2, right? Now 2 and 2 which is greater, 2, 2 and 3, 3, 3 and 1, 3, 3 and 0, 3, 3 and 1, 3, 3 and 2, 3, 3 and 0, 3, 3 and 1, 3, 3 and 0, 3, right? So these are the right maximum height of the buildings, right? So here you can see for 1, the which is the maximum height on the right side, there is nothing, right? So the current building height is only the maximum, right? Then for 2, which is the rightmost maximum height, that is 1, but the current building height of 2, so that's why we mentioned 2. Okay, now we have calculated the left maximum here, the right maximum here, and what will be the height of the water? What will be the height of the water? Will be the minimum of this. So let me calculate the minimum of this. Okay, height of the water. What will be my height of the water? So 3 and 0, which is minimum 0. 1 and 3, which is minimum 1. 1 and 3, 1. 2 and 3, 2. 2 and 3, 2. 2 and 3, 2. 2, 3. 3 and 2, 2. 2, 2 and 1. This will be the height of the water. And you can tally like here the height of the water is 0. Okay, height of the water will be 1. We will subtract here that is 1. We have not done one thing, right? There is one thing missing here. What you can think? Think in this term, right? Here, what is the height of the water? If I say that the total height of the water is 2, right? So height of the water is 2, but the collected water is, right, height of the water minus the current building height, that is area minus the current building height, right? This much water is filled, right? So we always need to subtract the current building height. So whenever we are finding height of the water, it will be minimum of height of left and maximum right maximum, and then we will simply minus area, right? Current building height, right? So if I simply move all these up a little bit, this one, and now we will calculate. We will simply do height. I can say that this will be the minimum of it, like this will be the minimum of HL max and HR max, and here we are calculating height of water, that is minimum HL minus HR minus area. Okay, so where is my area? That is this height of the building, right? 0 minus 0 will be 0, 1 minus 1 will be 0, here 1 minus 0 1, here 2 minus 2 0, 2 minus 1 1, 2 minus 0 2, 2 minus 1 1, 3 minus 3 0, 2 minus 2 0 1, 2 minus 1 1, 2 minus 2 0, 1 minus 1 0. Now here you can see this is your collected water, right? This is your collected water. You can see 0 0 1, this is your collected water. Then you have 1, this is your collected water. Then you have 2, this is your collected water. Then you have 1, this is your collected water. Now here you don't have any collected water, here not, here not. Then you have this collected water 1. So this is your collected water, right? And that's just what you need to do. You need to sum it. So it will be 1 plus 2, sorry, 1 plus 1 plus 2 plus 1 plus 1, and that will be the height of 6. Right. So this is how we need to calculate it, the height of the water here, and you can calculate by the prefix and suffix method. Okay, so that will be one approach. So how we are solving it? So basically, what are the things we want? So we want one left maximum array. Okay, that is for left maximum. Then we want right maximum, that is array. Okay, and then this is how we are calculating. So simply I will run a loop for that will I start from 0 to n. Okay, and here I will simply calculate my left element. So suppose left maximum of I will be equals to my maximum of the current building, right? So let me mention it like this: maximum of current building, that is height of I, you can say. Okay, and your left maximum, the last left maximum, that is I minus 1. Right, this is your left maximum of I. Will start from 0 to n. Similarly, same for this result, that will start from n minus 1 to, right, because we will start from this n minus 1 to your 0. Okay, so here you can see, like, if you start from 0, it will be 0 minus 1, which is not defined. So what you can do, you know that your, like, if you are starting from left maximum, that will be the your height of the, like, so what is the height of the building? That will be the left maximum first element. Here, what will the right maximum? Basically the height of the right. Okay, here, because the water will always flow from here, the water will always be flow from here, right? So I can directly mention this 0 and this 1 without any competition here. So I can start from 1, I can start from 1 and I can pre-fill the value with height of 0. Okay, similarly here I can start from n minus 2 and will go till 0, and same, exactly same, what we need to do, we need to simply do right maximum of I will be the max of height of I, and your right max I plus 1. This is how you will calculate both the arrays. Okay, once you have calculated both the array, what will be your water? So basically you will run a loop, calculate the height of the water. So simply one loop will start from, again we have pre-filled the value, so I can start from I1 to n or n minus 1. Again, it depends to you. It won't make a difference too much. So I will simply collect the height of, not height of the water, let's collect the total water. So how I will calculate the total area water? It's basically plus equals to your minimum of whatever you have covered in your left maximum I and your right maximum I. Okay, and minus height of the building, right? So height of the I. This will be our approach, and so this will run a loop till n. Okay, depending on the size of the array. Here this is also depending on the size of the array. Here also it is depending on the size of the array. So n plus n, that is 3n. Okay, again here that's a constant, so time complexity will be big O of n only. Okay, and space complexity, so what we are creating, we are creating a left maximum array and a right maximum array to creating, like, to find the right and left maximum. So again the size here will be big O of n, because the array depend on the size of the array. This will be till length of the array, right? That your height. Okay, so it will depend on n, it will also depend on same problem. If you want, you can optimize it. So you just need to think of it, that instead of collect creating both the values, like instead of creating a prefix array of left and a suffix array of right, we can solve it by only taking any one of it. So you can either take prefix or suffix. So let's suppose you are taking suffix and you are not taking prefix, right? You are not taking the left maximum. You can solve that problem. If you are not taking this left maximum, on the iteration, by taking a variable, you can find it. So you can create one variable of left maximum that will basically find out the left maximum till that building. Okay, and once you find out the left maximum till that building, you can simply uh, put it in here, right? Minimum of left maximum and right maximum, that's up to you. And so this will be the time and space complexity of it. Okay, the current time and space complexity will be big O of n, and space complexity will be big O of n. And now think, your, if your interviewer might ask you how you will optimize this approach, how you will optimize this, right? Is there in a better solution? So no doubts that the time complexity will be big often because we need to iterate from each building. But let's see how we can increase our space complexity. Is it possible that we won't take any of it, like not a left maximum array, not a right maximum array? So let's check out the problem again. So now let's see. Okay, now let's work on the approach 2 where we can solve this problem without taking an extra space. Okay, so basically for collecting the total area of the water, what we want, we are finding the minimum of left maximum till we get. Okay, I can represent it as h max of left and h max of right. Okay, and then we are simply subtracting the area. Okay, the height of the building basically. So this is, instead of area, it will make confused. You can say that height of the building. Okay, now, so basically why we want maximum left on the side, maximum right on the side, because we need to find the minimum of it, because that will be the height of the water, and this is how we will calculate it. But suppose there are two values, right? We have height maximum left and height maximum right. Okay, what will be the deciding factor for my height of the water? What will be the deciding factor of height of the water? It can be either maximum left or maximum right. Okay, it can be either maximum left or maximum right. So what we can do here, we will try that we won't need a suffix value, because when we are taking a suffix values, when we are taking right maximum array, we are saying that there are sure, complete sure chances that maybe there will be a smaller height on the right part. So why, what we are saying here, we are thinking that we will traverse to the smaller ones, because what we want, I want the smaller one. I want the smaller one. It can be height of maximum of left or maximum of right, but I want any one of it, right? And if I want only one of it, why I didn't need to do a pre-calculation, right? I can directly compare between these two and I can move it. I can simply move it. I will find out the smaller values, okay, between the two, and I will move it. Okay, so what we can do here, we can take two pointers. Okay, so suppose one pointer at L, one pointer R at here, and what I will do, I will create two variables again. I will calculate height maximum left that I got, and I will calculate height maximum right that I got. Suppose both is starting from 0, and we will move with the smaller values, right? Because I am more interested on these smaller values. Either it can be height of maximum of left or right, and then we will calculate the total area of the water. Okay, so suppose I am at the, like here, my one pointer is at here left and right. Which is the smaller one? Which is the smaller? 0 is the smaller one, right? So this is the smaller one. This can be deciding factor of my height of the water. Okay, this can be the deciding factor of height of the water. How I just need to check? I just need to check what is my maximum height on the left side, and that is on 0. So if both are same, right? 0 is here and 0 is here. Okay, both are same or greater, right? Or smaller, suppose height of maximum is smaller. Will the water will store? No, absolutely not. Water won't store here, because the current building height is of 0. Okay, your maximum left is also 0, so water won't be stored, right? Water will only store, suppose left is at 1, okay, and this is at 0, like this one. Will the water will store? No, right? The current building height is 1, but the left maximum is 0, right? There is nothing up building to store the water, to collect the water. Okay, so that is only possible, your water. Okay, your water will only be possible when height of maximum on the left side is greater than your height on the left part. Is this condition is clear? Height maximum left should be greater than height of the left building, right? Height of the current building where my L pointer is. Okay, similarly here, water can be stored only when height of maximum our right side is greater than my rth building. Okay, so maximum left should be greater than my lth building, maximum right should be greater than rth building, right? So here water won't be collect. I am at 0, height maximum left is also 0. So what I will do, I will simply move my pointer L here. Okay, once I move it, now I am at 1. Okay, and I will check what is my maximum left, that is 0, which is lesser than. So again water won't be collect, right? Water won't be collect. So what I will do, I will simply update it here. Okay, first of all, I need to decide which pointer I will move, right? My left is pointing to the building of height 1, my R is also pointing to the building of height 1. So here nothing, no one is smaller. Okay, no one is smaller. So I can either move right or left. It depends totally on me, right? So suppose I move left, okay, and I will update it because I'm moving here. I will update it. Now the left maximum on the left side is 1, right? So I have updated my left maximum is 1. Okay, now I have 0 here. Okay, my current building height is 0. My height maximum left that I have achieved, that is 1. So there is a chances of water storation. There is a chances of water collection, right? And you can see here my lth building is smaller than the rth building. So yeah, there are the chances of water collection. Okay, so what will be the water collect? Okay, so the water will collect till height maximum left minus lth building, right? So 1 minus 0, that will be 1. Okay, again, which is smaller, this is the smaller, I will move here. Okay, now rth building at 1, lth building at 2, which is smaller, my rth building, right? And you need to focus on the smaller parts, smaller buildings, right? So what I will do, I will simply move my r pointer and I will update my right maximum right building on the, like, maximum building on the right side. Now both are pointing to 2. This is also pointing to 2. This is also pointing to 2. I can either move left or right. Let's suppose if I move left, okay, I will update my left maximum with the 2 and I will point to the 1 here. Okay, my right is pointing to 2. Okay, and now see, left is pointing to 1, right is pointing to 2, and height maximum left, that is 2, right? So there is a chances that I can collect the water, right? Because maximum of left is greater than the lth building and lth building is smaller than the rth building, right? So rth building here, so there is a chances of water collection here. And yes, what will be the water, that is height maximum of left 2 minus the lth building. So l is at 1, so 2 minus 1 will be 1. Okay, again, which is smaller, L building is smaller, I will move and I won't update it because 2 is the most maximum on the left side. Okay, now R is pointing to 2, L is pointing to 0. Again, where is the chances of water collection? On the Lth building, on the Lth building. And how much water will be? So it will be 2 minus Lth building height. What is Lth building height? That is 0. So it will be 2 minus 0, that is 2. Okay, and again I will move it. I will move it. Now my L pointer is at 1. Okay, R pointer is at the height of 2 again. So what I will do, again there is a chances on the smaller ones. So left building height, there is a chances of water collection. Till then this much water is collected. Okay, so what will the height of the water, that is maximum left 2 minus current building height 2 minus 1, that will be 1. So this much water will be collected. Okay, and I will move my L pointer here. Right now, Lth building pointing to 3 height 3, Rth building pointing to height of 2. Okay, which is smaller, Rth building, right? Water won't be collect on the Lth building, that is the highest building we have got so far, right? So Rth building at 2, we will simply move it, which is smaller Rth building, we will move it and we will update the right maximum height we got till now, that is 2. Okay, now R is pointing to 1, L is pointing to 3. Again, where is the chances of water storation? Now Rth building, here is the chances of water storation. Okay, and how you can see height maximum right, that is 2, current building height, that is 1, 2 minus 1, that will be 1 water collection. I will simply move it. Okay, now left maximum is 3, right maximum is 2. Okay, and there is, which is the smaller building? The right maximum is the smaller building. Is there any chances of water collection? No, because the maximum right building you got, the maximum height building you got on the right side, that is 2. Okay, your current building is also 2, so that is not possible. It won't collect the water. Suppose if we got something as 3 here, then the water won't will be collect. Okay, but we can't get 3 here because we are moving with these smaller values. We are moving with these smaller values. So what I will do, I will simply move it, and I will simply like if I update it, it will be remain same, that is 2. And now both pointers are pointing to the tallest building in this area, complete area, the tallest building here, and that is the height of 3. I will stop it here and I will find out what is the total area that I have got. That is again 6. Okay, so this is also one approach that you can find and that you can solve it. Basically, the intuition to solve this problem, that I don't need two both the values on the same time, maximum left and maximum right. I will be required the only one, that is the smaller one. So I can bet on it कि height maximum left can be one of the building that I want, and this is, and what will the water is basically height maximum building minus current building height. So let's see how we can write the code of it. So so suppose you will take 2 pointers basically. Your left pointer is starting from 0, your right pointer that will be your length minus 1, n minus 1, and you can take 2 variables. Suppose left maximum with 0 and your right maximum with 0, right? So these will be your pointers, and simple one loop will be there, that is while L pointer is less than R. Okay, while L pointer is less than R, you will calculate if, okay, how the water will be stored. If your current building, right, is smaller than the Lth building is smaller than the Rth building, that's the only thing, right? So if height of Lth building is smaller, or let's suppose, because equal cases will also be there, is smaller and equal, what I will do, I will move my L pointer, right? So my height on the Rth building will be this one. Okay, so if this is the case, what I will do, I will move the L pointer. I am talking about the L pointer here, right? And else, if this is the case, okay, I will move my R pointer. Okay, so one thing is sure, that here I will move L plus plus, here I will move R minus minus. Okay, now inside it, there is a condition when your water will be collect. Okay, your water will only collect when your left maximum should be greater than your Lth building, right here. Yes, so it should be greater than the your Lth building, then the only possibility of water is collection. Yes, so if this is the case, what you will do, create a total plus equals to basically a difference of it. So left maximum minus your height of L, right? This will be your difference, will give you the value. Else, suppose this is not possible, like your left maximum is smaller than your height. So what you will do, you just need to update it and move it. So suppose here, if the case is opposite, what I will do, I will simply update it. So I will update my left maximum, basically the height of the building, height of the Lth building. Same case, exactly the same case will be here. I will collect water only when my right maximum is greater than the height of the Rth building, right? If this is the case, then I will basically collect the total water plus equals to my right max minus height of the right building. Okay, else if this is not the case, my right is smaller than, so what I will do, I will update my right maximum. I will update my right maximum equals to height of the Rth building, and there will be an R minus minus L plus plus. This is the only thing, right? So you are moving your pointer, L and R both will meet at the same point. You will decrease the iterations so much, but suppose your all the buildings are smaller one by one, like suppose this one, then this one, then this one, then this one, right? Okay, a building is something like this, water won't be collect. Okay, of course water won't be collect here. Okay, but if this is the case, your L pointer will simply move from here to here to here to here, right? So the time complexity for this approach will be big O of n. Okay, depending on the size of the height of the buildings, number of the buildings. Okay, and we are not taking any extra space here, so space complexity will be constant, that is big O of 1, right? So here we have discussed two approaches. Okay, both approaches were like very prominent. Okay, you can apply both the approaches. Both approaches solution will be accepted on Leetcode. In the next video, we will check how we can implement both the approaches.